Hey guys, welcome back to ITower. Today we're building a mini middleware framework from scratch. If you've ever wondered how Express handles requests or manages that chain of operations before your route handler executes, it's all middleware. This video will give you deep insight into the architectural patterns that power modern web frameworks. You'll learn how to construct a flexible system for processing requests, understand request pipelines, chain functions together, and manage control flow. By the end, you'll know not just what middleware is, but how it's built and why it's so powerful. This knowledge is crucial for building robust, scalable backend services and will set you apart in interviews and architecture discussions. Before we dive in, please hit that like button and subscribe to ITower. Your support helps the channel grow and reach more developers. It genuinely makes a huge difference, so thank you. Let's talk middleware. At its heart, middleware is a series of functions that process requests before they reach your final handler. Think of it like an assembly line. Each station performs a specific task like login, authentication, or parsing, then passes a request along or terminates it. The beauty is modularity and reusability. Instead of cluttering route handlers with cross-cutting concerns, you encapsulate them into separate middleware functions. Why not just one big function? Because separating concerns makes code easier to debug, test, and update. If login changes, you modify one middleware, not every handler. This pattern is in almost all modern frameworks because it's powerful, flexible, and elegant. Now let's build our framework. We'll start by defining a class to manage our middleware. This class manages our middleware collection and executes them in sequence. Using a class gives us clean encapsulation of state and behavior, keeping everything organized in one logical unit. In the constructor, we initialize an empty handlers array. This holds all middleware in the exact order they are registered, which is critical because execution order matters. Login must happen before authentication, authentication before authorization, and so on. The array preserves this order perfectly. The use method takes a handler function and adds it to our handlers array. The name uses a convention from Express, making our framework instantly familiar to anyone who's worked with Node web frameworks. This simple method is powerful because it lets you build up your middleware stack piece by piece. The execute method takes a context object representing request and response data, and a done callback that fires when all middleware completes. The context is a shared data container that flows through every middleware, accumulating information along the way. We declare an index variable starting at 0 to track which middleware we're currently executing as we navigate through the handlers array. This acts as our position marker in the middleware chain. We define an inner function called next. Each middleware calls this to advance execution to the next handler. This gives middleware complete control over request flow. By passing this function to each middleware, we are giving them the power to decide when and if to continue processing. We check if index reached the end of handlers. If so, we've processed everything, so we call done if it exists and return to stop execution. This boundary check prevents errors from trying to access handlers that don't exist. We grab the current middleware function from handlers using our index. Using a constant here is appropriate, because we won't reassign this value is the specific middleware we're about to execute. We increment index before executing so the next call to next points to the subsequent middleware. This increment before execute pattern is crucial for maintaining correct order through the chain. We invoke current handler, passing context and next. This is how middleware receives data and controls flow. Each middleware can read from context, modify it, decide whether to call next to continue or simply not call it to stop the chain. This is the secret sauce that makes middleware so powerful. We call next for the first time to kick off the chain reaction. First middleware executes, calls next, triggering the second, and so on. Now let's use our framework. We create an instance of middleware stack. This app object is our entry point for adding and executing middleware. Our first middleware logs when requests arrive. We log a message to the console showing the timestamp. Then we add a log message property to context, demonstrating how middleware augments context, with data for later middleware to use. Finally, we call next to pass control forward. Without this next call, the chain would stop here. The auth middleware simulates authentication. We log a message indicating authentication is happening, then add a user object to context with ID and name properties. In production, this would verify JWT tokens or check databases. We call next to continue, but if authentication failed, we might not call it at all, effectively stopping the request and returning an error. The parser middleware simulates body parsing. We log a parsing message, then add a body property to context containing our parsed data. In Express, this would be like body parser middleware transforming raw request data into usable JavaScript objects. At this point, context has been enriched with login info, user data, and now parsed body data. The final handler is the last step in our chain. It logs a processing message, then logs the complete context object to show all the modifications made by previous middleware. Finally, it adds a response property. Notice, it doesn't call next because there is no subsequent middleware. This is the endpoint of our processing pipeline where actual business logic would execute. We register all middleware using the use method. Order is crucial here. Logger goes first, so every request is logged before any processing. Auth comes second because we want to authenticate before parsing bodies or executing logic. Parser is third to transform request data after we know who the user is. Finally, the handler processes everything. We create a request context object simulating an HTTP request. It has a method property set to GET, a URL pointing to an API endpoint, and headers with content type. In a real framework, this data would come from the actual incoming HTTP request, but we are mocking it for demonstration. We call execute with request context and a done callback. This kicks off the entire middleware chain. The callback fires when the chain completes, logging the final response that was set by our final handler, and displaying the complete context state showing all accumulated data from every middleware. Now let's move to testing to see our framework in action. We'll observe console output demonstrating how each middleware processes context sequentially and how control passes from one to the next. We're testing that middleware executes in correct order, modifies context as expected, and the done callback fires when everything completes. This proves our framework implements the middleware pattern correctly. When we run this, we first see the logger message with timestamp, confirming login happens first, before any other processing. Then the auth message appears, showing authentication runs second and successfully adds a user object to our context. Next, the parser message confirms body parsing happens in the right sequence after authentication. Finally, final handler logs the complete context object with all accumulated data. We can see log message from the logger, user from auth, and body from parser, all present together. This demonstrates how each middleware contributed its piece to build up the complete request context. After the entire chain completes, our done callback executes and logs the final response message and complete context state, proving everything worked correctly. This sequence confirms our middleware stack works perfectly, with each handler getting its turn, modifying context, and passing control along the chain. So, today we built a working middleware framework from scratch. You gain deep understanding of function chaining, context passing, and modular design. These skills apply everywhere: Express, Koa, serverless architectures. This knowledge makes you an architect who understands the mechanics, letting you debug effectively, design better systems, and contribute to open source. The middleware pattern appears across frontend and backend. Redux middleware, React lifecycle, promise chains all use similar concepts. This foundational knowledge makes you better across the entire stack. Thank you for watching. If you enjoyed this, please like and subscribe to ITower. Your engagement helps create more free, high-quality content. See you in the next video.